Yes guys, welcome back to our channel that we are going to discuss about the position time graph as you know very well. So object does not change its position with respect to time, point number 1. Object remains at a constant distance x equal to x naught from the origin. And in this graph, the graph is said to be as a straight line. Graph is said to be as a straight line. Graph is said to be as the straight line parallel to x-axis. Parallel to x-axis. Sir, how can we define it is parallel to the x-axis? Let us draw the graph and try to understand. So as you know very well, this is my x-axis, this is my y-axis. This is my x-axis, this is my y-axis. So in this x and y-axis, I'll consider this is my O. So in the sense, it is an origin point. An object is placed at this point, that is x naught. So it is parallel to the time axis. I hope you will be very clear. So if you correlate the point, object does not change its position with respect to the time. Object does not change its position with respect to time. Here we can also say that x equal to x naught. Object remained at a constant x equal to x naught from the origin. So from origin, object remains constant. It is always remaining as an constant x equal to x naught. And at the same time, in this graph is a straight line parallel to x-axis. The next very basic point we are going to discuss about is nothing but the position of a time in a uniform motion. Position time graph for a uniform motion. Sir, how can we define this? Position time graph. Position time graph for uniform motion. For the uniform motion. Position time graph for the uniform motion. So how can we define the position time graph for the uniform motion? We have to draw the graph, obviously. There is no doubt about that. We have to draw this graph by making this is my x-axis and this is my y-axis. So this is x and this is my y. So I have to draw in between the components, that is time is comparing in the x-axis, and we have to say position is in the y-axis. This point is also very clear. I have to take this graph originating from x naught point, which is inclined at an angle inclined to the time component or x component. So I'll say this is my x naught position, correct only na? So I will take one random point from this parallel to y-axis, parallel to x-axis. I'll take even one more parallel point parallel to x-axis, parallel to y-axis, and I will want to make a slope of it. I want to draw the slope of it. So in this slope of it, they are inclined at an angle theta, point number 1. And if I want to define this point, this is x2 minus x1. Sir, how could be possible? I'll say initially, this point is close to 0, so I'll say t1. This point is next to t1, so it is t2. Point, I hope you will be very clear. So distinguish between these 2 points are t2 minus t1. Similarly, for this x point, can you define x? Since it is very closer to x, so x1, next to x1, that is x2. So which is also considered as x2 minus x1. So slope of an uniform accelerated motion, slope. If I want to know the slope of an uniform accelerated motion, xt graph, slope of an xt graph, how will you say that? Uniform accelerated motion will be first formula y by x. I can say y by x, or even I can say delta y by delta x, or I can write it as dy by dx. So here I have to define that y2 minus y1 divided by x2 minus x1. Point number 1 will be very clear. Next, the next point I have to understand about the substitution. So what is the formula I can substitute here? Sir, here x2 minus x1 is the quantity. So I will write it here as x2 minus x1 divided by time is the component existed there. So t2 minus t1. I hope you will be very clear. So this is the formula, just a formula. y by x, delta y by delta x, dy by dx. Both are same only, no change. We, in expansion to that, we can write y2 minus y1 by x2 minus x1. So this is my real formula, that is tan theta is equals to. So the slope means what? Tan theta only, na? Slope means obviously tan theta only, na? So tan theta is equals to, we can write it as x2 minus x1 by t2 minus t1, that is velocity component displacement component divided by time is called as velocity, which is considered as the velocity. Displacement by time considered as the velocity. And the next we are going to talk about the certain points which we have to measure for the uniform motion. What are the points we need to sum up for the uniform motion? An object in uniform motion, what will you say about that? An object in uniform motion, what are the points you need to sum up? An object in uniform motion. So how will you sum up the point? That is nothing but it covers equal distance in equal intervals of time. Point number one is it covers equal distance. It covers equal distance in equal intervals of time. Equal distance in equal intervals of time. Point number one. Equal distance in equal intervals of time. Point number one. Next we are going to talk about position time graph for any object or by a uniform motion. It exists along the straight line path. It exists along the straight line path. It is existing along the straight line path for an object in straight line path in a straight line which is inclined to the x-axis. In a straight line inclined to x-axis. An object in the uniform motion, how it has to be like? It covers equal distance in equal intervals of time and it exists along the straight line path in a straight line inclined to the x-axis. X-axis in the sense time axis. X-axis in the sense time axis. I hope you will be very clear. So let us recap the points which is you have studied already, that is position time graph, xt graph. Xt graph from a stationary object is object does not change its position with respect to time. Object remains at a constant x equal to x naught from the origin, and in this graph is a straight line parallel to x-axis. So this is the diagrammatical representation. Even if you want to mention with respect to this diagram by the highlighting, you can understand, no problem in that. Next we are going to discuss about the position time graph for a uniform motion. You know what is uniform motion? Equal distance in equal intervals of time, and the same uniform motion graph exists along the straight line path in a straight inclined to the x-axis or time axis. And this is the derivation part, like slope of an x and time path is how much is that y by x or x2 minus x1 by t2 minus t1. So tan theta is equals to, that is x2 minus x1 by t2 minus t1, that is called as the displacement by time, that is velocity. So at last, the slope of an position time graph, you have to write the final conclusion point. Slope of position time graph. What is the slope of position time graph? Position time graph in a uniform motion. Position time graph for an uniform motion is nothing but uniform motion gives velocity. It always gives an velocity. I hope you will be very clear. Okay. So We have one more segment that we'll see in the next segment. Though if you like to this video, kindly don't forget to subscribe and comment on this. If you find any difficulties also, you can comment and ask your queries. We are going to discuss about the position time graph. Position time graph. Position time graph for an uniform accelerated motion. For uniform accelerated motion. So what is an uniform accelerated motion? Uniform accelerated motion. So what is the position time graph for a uniform accelerated motion? So let us discuss. Uniform acceleration motion will be always considered as the equation x minus x naught is equals to ut plus half times of at square. So this is the equation. Sir, can we write s is equals to ut plus half times of at square? Yes, exactly, you are correct. So position time graph for an uniform accelerated motion. This is the derivation part which we need to concentrate. By drawing the graph, we will try to elaborate this segment. So first we'll try to draw the graph. Let us see, check out the graph first. So this is my graph for x-axis and this is the graph for an y-axis. X segment, what is the quantity existed? Time. What is the quantity existed? Position. As you know very well, it is a position time graph. So here we need to draw a curve which is an increasingly randomly changes with the time. So this point I will consider it as x naught point, and with this I will calculate the position. Here also I can able to calculate the position time graph for a particular point by drawing a slope. And I will want to mention parallel to x component, parallel to y component. So here if I consider this segment will be obviously called as the x2 minus x1 segment because it's a position. It indicates purely it is an position segment. And if I want to go with this lower segment, that is t2 minus t1, as you know very well. So which is considered as the time. So let us highlight this point first. x2 minus x1 is the position segment. Difference in position. Difference in the position segment. Am I right or not? Next, we can also write t2 minus t1 is equals to time segment. Difference in the time. Difference in the time. So with this graph, what can you define that? It is nothing but point number 1, x is proportional to t square. If x is proportional to t square, then we can also call it as x is a quadratic function. X is a quadratic function of t. Quadratic function of t. X is a quadratic function of t. Point number 2. So position time graph for a uniform accelerated motion is an parabola. So the position time graph or xt graph, we can say xt graph for a uniform accelerated motion. Uniform accelerated motion. What we can say here? Uniform accelerated motion is parabola. Uniform accelerated motion is a parabola. It is said to be as a parabola. I hope you will be very clear. And the next point we are going to discuss about is the slope of an position time graph. Slope. How can we define the slope of an position time graph? Xt graph. What is the slope we can define for an xt graph? That is nothing but small change in vertical coordinates. Small change in the vertical coordinate followed by you have to draw a slope of it divided by the small change in horizontal coordinate. Small change in the horizontal coordinate. Small change in the vertical coordinate with a small change in the horizontal coordinate. We'll substitute this value like x2 minus x1 divided by t2 minus t1, which we can also write it as delta x by delta t, or we can write dx by dt. So we can define this problem as velocity at that instant of time. We can also write it as velocity. We can also write it as velocity is equals to dx by dt. So this is our required equation through which we can have derived from the uniform accelerated motion. Through this equation we have defined that uniform accelerated motion, we have defined velocity is equals to dx by dt. So the last point we would like to conclude is slope of an position time graph. Slope of an position time graph will give me always instantaneous velocity. Instantaneous velocity. So position time graph dx by dt always give me that instantaneous velocity, and at the same time the slope of an xt graph also gives me graph also gives me the initial velocity, also gives me the initial velocity, that is u, initial velocity as u at t is equals to 0, at t is equals to 0, condition number 2. So we'll recap the point. As we know the equation that x minus x naught equal to ut plus half at square, which is also equal like an second equation of motion, as you know very well. So the position time graph for an uniform accelerated motion is, this is the graph, required graph, x, y, position, time, x2 minus x1, t2 minus t1. So point number 1, x is proportional to t square, x is in quadratic equation. Point number 2, st graph for an uniform accelerated motion is a parabola. It is always parabola. The slope of an xt graph we have defined in the derivation form, change in the vertical coordinate by horizontal coordinate. So we can write dx by dt. So dx by dt is nothing but velocity. So this gives me, from this graph what I have result value is the instantaneous velocity, and at t equal to 0 I am obtaining an initial velocity u. I hope you will be liking the channel. Please don't forget to subscribe. Don't forget to comment on it. Thank you for the patience, and thank you for the subscribing the channel. Thank you very much.